In the last section, we got to have a good discussion about how the React server and the Express server are working together and the differences between them in the development world and the production world. We're now going to continue in this section with what is going to be another pretty long video. So I'm going to preface this right now. I'm going to say this is a long video. So this is the one where we are going to go into a lot of kind of crazy stuff where we talk about a lot of the intricacies of our server. I want to make sure that it's really clear to you this is completely optional. So if you don't want to hear about any of this server setup or proxy stuff or blah, 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 how all this stuff is working, that's totally fine. You don't really need to know this stuff to be able to build applications. But of course, I'm going to tell you, this is how you get to be a really good engineer. So of course, I recommend that you watch this. Okay, so if you're still here, and I know you're all here, I know you are, let's get to it. So we're going to talk about a couple different issues. Again, this will be a long video. I apologize ahead of time, but I want to do everything just in one single video, so we just kind of get it all out of the way and talk about all these really important concepts that are kind of going on behind the scenes. Okay, so I want to reiterate the fact that as we've spoken about the server so far, everything works well. It's very elegant. It works very well in development and works equally well in production. Everything feels fantastic. But as soon as we start talking about some of the inner workings, you very likely will say to me, and why are we doing things this way? It seems crazy. So I can't say it enough. At surface level, it works together very well, and it's a completely reasonable server setup that we have right here. But once you start to understand the inner workings, you really get the feeling that, wow, there really are a lot of moving parts here, and there's just a lot of stuff that's happening, okay? So let's dive into it. The first thing I want to do, if you recall, in the last section, we had updated that redirect URI, and I had said that it takes some time for this thing to actually percolate through. We didn't actually get back to testing it in the last video. That was my mistake. So just really quickly, if you go back over to localhost 3000 and click on sign in with Google, the redirect URI should now be whitelisted, and you'll see something like this. You can authorize it, and you will eventually end back at that same kind of error message that we've seen all along. So again, this message right here is totally fine. We'll come back very shortly and fix it all out. So it looks like, yes, the OAuth stuff is working correctly. So I want to now start talking a little bit about our general server setup and why we made some of the decisions that we did. Maybe not why we made the decisions, but I want to make some of the considerations clear, okay? So the first thing you might be sitting here wondering is, why do we have whatever, even I can get by the two separate servers like this, whatever, I can deal with it. But, I understand why they condense down into one server like this, but why didn't we take some type of other more reasonable approach? Something like where we have something that looks like this, where we have one create React app server that serves up the bundle.js file. Then we have a completely separate API, and we just say, you know what, let's stomach it. We're just going to deal with handling these different domains. We'll figure out some elegant solution, whatever, we'll figure out. I don't care about having to specify the domain between production and development. We can figure that stuff out. And besides that, maybe we even want to have an approach like this, because maybe we are trying to work with some other existing API that doesn't really have the ability to take a React.js app on top of it. Maybe you are working at a large enterprise company where you have teams and teams of engineers working on really heavy backends that are solely intended to be used as API servers. And so we don't want to deal with any of this route condensing stuff or anything like that. We want to have this distinctly separate, very different API on a different domain that we can always access no matter what. So I'm going to say, okay, you know what? Hey, that's totally fine. I have even advocated around approaches like this in other courses of mine. I've very clearly said in other courses, yes, we're going to have one server that serves up all the front-end development assets, and then another that acts as the API that serves up all the information for our app. So this is a completely fine approach. Don't get me wrong. We certainly could have taken our application in this direction. We could have certainly put together some type of architecture like this. But there's a couple of reasons that we were prevented from doing this easily inside of our application, okay? Now, I'm going to use the word prevented very carefully. I'm going to say that we could have worked around these issues with some challenges. We could have gone in this direction, but we decided to keep things easier and straightforward and kept them the way they are. So I'm going to lay out those two issues. and lay out the two kind of reasons that made our life easier by taking this sort of approach right here, okay? So the first reason, I want to remind you that we are using cookies as the absolute linchpin for authentication in our application. We have said repeatedly, once the user goes through the OAuth flow, we're going to set up some type of information in the user's cookie that's going to identify the user, and then every subsequent request back to our server will contain that user's ID. And that's it. That's the whole shebang. That's how we're doing authentication, right? And we've spoken at such great length about this. So here's issue number one, and here's the reason why we took our particular architecture. Let's imagine that we have some browser that is currently pointed at localhost 3000. If a browser at localhost 3000 makes some type of AJAX request, like let's say we're trying to access our API, fetch a list of surveys, or whatever it is we're trying to do inside of our app. When we make that request to a server at localhost 3000, which is the exact same domain that the browser is currently at, cookies will be included with the request. However, if we make a request to localhost 5000, so in other words, to some different domain that houses our API server, cookies are not included with that request by default because our browser is currently pointed at localhost 3000. Now, this is purely a security issue, purely security. The browser assumes that if you are at localhost 3000 and you make a request to localhost 3000, hey, you know what? No problem whatsoever. Include the cookies, everything is fine, make it happen, who cares? But if you're at localhost 3000 and you make a request to localhost 5000, well, all of a sudden the browser starts getting really suspicious. The browser starts thinking, why is this web page trying to make a request to localhost 5000? Why are they trying to make a request to a different domain, to a different server, to a different port, specifically a different port here? The browser assumes that it might have loaded up some malicious JavaScript code that is attempting to make a request maliciously to some different domain. And so by default, the browser will not include cookies with that request. Again, solely a security issue, and it's completely triggered by the fact that the browser is currently visiting one domain, and we are trying to make a request to a different one. And yes, a different port counts as a different domain. So it can be, this could have just as easily been like we were at google.com and trying to make some AJAX request to like airbnb.com. So if our browser was pointed at google.com and we made an AJAX request over to Airbnb, cookies would not be included with that request by default because it's a different domain. Again, purely a security concern. So again, by using localhost 3000, by keeping this, or by, excuse me, let me back up for a second. Let me just say, by taking this sort of architecture where we say we are always making a request to localhost 3000 and then we rely on create React app to forward that request onto the API, we completely skirt this entire issue. As far as the browser is concerned, any API requests we make at all from the browser will always be pointed back at create React app in development, and then create React app will automatically proxy that request onto the Express API. The browser does not know that that proxy is there. The browser doesn't know, it couldn't care. So the browser makes the request to the proxy. It's thinking, oh, hey, I'm at localhost 3000 and I'm making a request to the server at localhost 3000. Sure, same domain. I'm going to include the cookies. Everything is a-okay. Then the proxy takes that request, it takes a copy of the cookies and forwards it onto the Express API. And so as far as you and I are concerned on the Express API, hey, we got our cookies. We know who this user is. We're going to formulate a response and send it back, and it's eventually going to end back up at the server. And then of course, as we've discussed, inside production, that that create React app server falls away. And so in production mode, the browser will always be at herokuapp.com or whatever. We're going to make a request to our Express API on the same exact domain. And so none of this cross-domain cookie stuff is an issue at all. Okay, so that's reason number one. So in this case, you know what? The browser does have APIs to allow us to send cookies across domain. It's there. We could take this approach. We could do it. We can make it happen. But again, I'm just saying life is easier when we don't have to worry about these advanced issues, right? We just don't have to worry about it now. We can use cookies. All the authentication stuff is pretty straightforward, relatively, at least as far as the browser is concerned, and life is easy. Don't have to worry about JSON web tokens. Don't have to worry about headers or anything like that inside of a React app. Everything, we just have to go through the OAuth flow, and boom, we are magically logged in. So in this case, again, I'm going to say, you know what? This sounds like it's crazy. It sounds like it's very complicated, but we decided to take the approach we did because it was a very easy, straightforward approach. So again, I really stand by the server decision we made. Okay, so this was big issue number 1. Big issue number 2. And this issue is nearly identical in nature. Okay, so basically identical, but it's just slightly different topic. So again, let's imagine that we are in the browser on localhost 3000. If we are in the browser at localhost 3000 and we attempt to make some type of AJAX request to a server also located at localhost 3000, the browser says, okay, fantastic, no issues here whatsoever. Go ahead and make your request. Everything is a-okay. However, again, as a browser security feature, if we attempt to make a request from localhost 3000, we are visiting localhost 3000 in the browser, and we attempt to make a network request over to a different domain or a different port, that is counted as what we refer to as a CORS request. CORS is short for Cross-Origin Resource Sharing. And if you've been doing web development for a while, you've probably at least seen the error message and probably done some endless Googling on how to fix it, I would bet. It's something that most web developers usually fall into eventually. They eventually see a CORS request, and they'll eventually do some Googling to figure out how to get around it. So this is another issue that is very closely related to this cookie stuff. When we are in the browser at domain localhost 3000, we can make free AJAX request to the same domain, no issues whatsoever. Everyone's happy. As a security feature, again, 100% security related here, 100% security related. The browser assumes that if you are at the domain localhost 3000 and you make a request to a different domain, the browser assumes that you are trying to do something malicious. Like the browser assumes that it accidentally loaded up some bad JavaScript, some malicious JavaScript, and something bad is attempting to make a request over to a different domain. So the entire idea behind CORS, again, it is entirely a security issue that the browser places, or a security issue that the browser places upon requests that you try to make from it. Now again, I can't say it enough. Yes, we could have got around this. We can configure this localhost 5000 server, this Express API that we put together, we can configure it in such a way that it says to the browser, hey browser, you know what? You're making a cross-origin request, but that's totally fine. Come on in. Browser, it's safe. It's completely fine. Allow the request. Here's the JSON you were looking for. Here's the information. And so again, I'm going to say to you a second time, we could have worked around this. We could have solved this issue. Totally possible. But by not having to worry about making requests to this separate domain, because we've got the proxy here, everything is fine and it just works out a-okay. And so just to make sure things are really clear, let's kind of review why we don't have to worry about CORS in our setup. So again, it all comes down to the proxy. In the development world, whenever we make a request from the browser, we're going to make the request to localhost 3000/API/whatever. That will be sent to the proxy. The proxy will then forward the request onto the Express API. The API sends a response back, and then it's communicated back to the browser. As far as the browser is concerned, it only ever made a request to localhost 3000, and it doesn't think that CORS is even remotely an issue here, even though the server actually is being ran on localhost 5000, which would qualify as a CORS request. So again, the proxy really saves us in development mode. Now in production, again, same thing as before. When we are in the production world, the browser is going to see in the address bar bayou.herokuapp.com or whatever your randomly generated thing here is. And so when we make an API request from the browser, while the browser's at herokuapp.com, and we make a request back to our Express server, which is located at herokuapp.com, it's the same domain. So again, CORS are not an issue, just like cookies were not an issue as well. Okay, so hopefully at this point, I've given you at least a little bit of a better sense why we chose to not necessarily take this approach from the get-go. Now, again, I want to say one more time, I have advocated for this approach in other courses of mine. One of my other courses, I explicitly show how to set up a server with this type of setup. But just to give you, a little bit of variety here, show you something different, make sure that you can use Create React App effectively, all that kind of stuff, we're taking this other different approach. All right, so now we get into the real deep stuff. This is the last thing we're going to talk about in this section. If you want to, feel free to take a pause right now, pause the video, grab a drink, come on back. This is the last thing. And in this last thing, this is maybe the real critical part. I don't know, this is the part that I personally think is important. We're going to walk through the entire OAuth flow of our application with the proxy involved. So by going through this flow, it's going to be really nasty, I promise you, but you will get a much better sense of exactly what the proxy is doing. You'll get a better sense of what the browser is doing with the Google API, all this kind of stuff. So we're going to walk through it in the development mode, and then we will also walk through it in production as well. Okay, so let's get to it. So you're going to love this diagram. Seriously. Yeah. All right, here we go. So this is how the proxy is working with our Express API in the development world. So at the very top, we got our browser. Here's the Create React App and the proxy. Here's our Express API. And then over here, we have Google. So we're going to walk through this flow step by step to give ourselves a better sense of what the proxy is doing and how some of this stuff just seems to magically work. Now, before we go through the flow, one very critical thing I want to remind you about. Remember that if we ever specify a relative path like anywhere inside of our application, like anywhere, the browser will automatically assume that this relative path actually means whatever the current domain is, /auth/Google. Okay, that path or that domain being prepended onto this relative path right here is extremely critical to understand as we go through this flow, because it is what makes everything really work very nicely. Okay, so just remember that fact. The browser will automatically prepend on the domain. Okay, so let's do this. Honestly, it won't be that bad. We've really covered the details of everything that's going on here already, and so we're just kind of reinforcing some of the stuff. So really, it's not bad. Okay, so here we are. We're in the browser. Right here, let's assume that the user is at localhost 3000. They see some link that says as an href /auth/Google. Now, when the user clicks on that link, the browser sees that it is a relative path, and so it's going to automatically prepend on localhost :3000. So it's going to turn to localhost 3000 /auth/Google. The request is issued, so the browser says, okay, looks like we're navigating. I'm going to go to this other location. I'm going to go to this other route. So it goes to the Create React App server and the proxy that sits inside of it. The proxy sees the request incoming to /auth/Google. When that request comes in, the proxy automatically looks into its package.json file and it says, this person is trying to make a request to /auth/Google. Do I have any settings around that route? And of course, yes, we do. So the proxy says, hey, you know what, Create React App, I'm the proxy, I got this. I'm going to take it from here. So the proxy sees that incoming request, it decides that it is responsible for that request, and it tells that request to just sit. It says, hey browser, hold up for a second, I'm going to figure out what to do with you. The proxy then takes that exact request and copies the entire thing, word for word, line for line. It takes the exact same request and completely copies it. It then takes that request and sends it on to the new route that we had specified inside of the the proxy configuration. So in this case, it's going to take that copied request and send it to localhost 5000 /auth/Google. So now the request from the browser is still sitting there, still pending. The proxy has sent this request out to the Express API. The Express API picks up the request. It says, oh, hey, okay, I see that you're trying to OAuth. No problem. To get into our OAuth flow, please go over to google.com. So you're going to go over to google.com, and after that, here is your callback URL. The callback URL. Remember, the thing that we had specified in the Google strategy. So where's our Google strategy? Right here, passport. So here's our Google strategy. We had specified that callback URL with a relative path. So we said, when you come back, go to auth/google/callback, okay? So that response is formulated up by the Express API. It sends it back to the proxy. The proxy takes the response. It takes the pending request that was sitting there from the browser, and it sends it on back. So it sends it on back to the browser, and now the browser is over here thinking, oh, okay, I guess I need to go over to Google. That's what this request that I just made. Little does the browser know that the proxy actually kind of copied and did all this stuff. So the browser thinks, okay, I need to go to Google right now. I'm going to go to Google, and then on return, I'm going to go to /auth/google/callback. That is a relative route. The relative route is going to be automatically turned into localhost 3000. Localhost 3000. So when we get that callback, when we get redirected by Google, Google is going to attempt to send us back to localhost 3000, not 5000, not the Express server. Okay, so that's kind of like real piece of magic right there, number one. That's totally awesome for us. That really works out well. So the browser continues on to Google. Over at Google, the user sees that consent screen. It says, hey, these email-y guys, these total like whack jobs want to get access to your profile. Is that okay? And the user says, yep, that's okay. So Google then says, okay, authentication done. It's time for you to go back to localhost 3000 /auth/google/callback. So we go back to that address. And remember, this time around, when we come back from the Google OAuth flow, we also put our code in there as well. The code is in the URL from the Google API, from the Google OAuth flow. So we get sent on back. And the request, again, at localhost 3000 runs into the proxy. Again, same flow as before. The proxy sees this incoming request to localhost 3000 auth/google/callback. That will be picked up by this same rule right here. Even though it says, /callback, it's still going to be picked up by this request right here. So that proxy is going to say, okay, I'm in charge of this route. I'm going to take things over. It copies the request. It sends the request to the API. Our API takes the profile, it takes the code that was in the URL. It goes and fetches the profile. It does all that fancy stuff that we spoke about endlessly. And then when everything is said and done, it sends back some response that says, okay, you're logged in now. Here's your cookies. Hope you're happy. You're logged in. Everything's fine. So the Express server then responds back and says, okay, everything looks good. Sends a response back to the browser, and everyone's happy. Now, the one thing that this diagram does not correctly have is on the diagram, I'm saying that after the Express API collects the user details, sets the cookie, does all that stuff, I'm saying that it tells us to go back to the route of / right here. We have not actually done that just yet. Okay, we haven't actually set that up inside the server, but we will very shortly. So at the end, the server is essentially going to say, okay, I've got everything, go back to / or essentially do a redirect. And when the redirect is sent back to the browser, again, the Express API is going to say, just go to / or like the root route in our application. And again, the browser is going to interpret that as meaning go back to localhost 3000 / because it's going to automatically prepend on the current domain. Oh, okay. So that's the flow. That's how all this OAuth stuff works. Again, the entire linchpin here is the fact that the browser automatically prepends on the domain to any relative route. That's what makes things just work like really nicely for us. So now we've gone through the dev flow. Very quickly, I want to go through the production flow, but it's much more simple, much more straightforward. So let's do this very quickly. Let me zoom in just, let's do 150, what the heck. Okay, so again, we're up at the browser. Again, this is production. That means we no longer have the Create React App server, so everything is just running on our let me get in here, the bayou.herokuapp.com domain. So this time around, in production, the user clicks on that button that says, take me to auth/google.com. And you know what? I actually put in my notes here, I said that at this point we're on emaily.com. It doesn't really make a difference. Let's assume that we buy a domain name and associate it with our Heroku account. So let's just assume we are at emaily.com. So we are at emaily.com. We click the start button. The start button has a link, or not start, but log in with Google. It has an href of /auth/Google. The browser will automatically prepend on emaily.com. So the browser gets sent on to our Express API. Remember, in production, we no longer have the create React app server. We no longer have the proxy. And so everything behaves much more predictably. The request goes to the API. The API says, oh, you're trying to OAuth? Okay, go over to Google. When you are done with Google, go back to /auth/Google/callback. So the browser then says, okay, everything looks good. On return, I'll go to /auth/Google/callback. We go to Google. OAuth is complete. We go back to emaily.com because that is what the browser decided to go to when it prepended the URL or the domain onto the link. We could then go back to the Express API. We serve up the code that is included in this callback URL right here. So really this would have, the code equals 123, whatever. Our Express API fetches the user profile, sets the cookie, and then eventually dumps the user back at the root route of our application. Okay. So I'm talked out. I'm not going to lie. I'm talked out. At this point, we have spoken about how our application works in the development world and in the production world. At this point, you might be thinking, this development or this server architecture that we're using is ridiculous. Why do we have to deal with any of this stuff at all? Well, again, let me point you back to exactly what we said at the start of all this. We had originally said that to get everything to work, all we really have to do is set this proxy right here. And then everything just kind of magically happens for us. It all just kind of works. But in the real world, what's really happening is this very complex flow and this crazy series of operations that works so crazy in tandem with the OAuth flow. And it really relies upon these very specific pieces of web architecture, how the browser works, and all that kind of crazy stuff. So if you are now sitting here thinking this architecture is crazy, again, you know what? It works just fine. It's super smooth. You don't have to worry about all these behind the scenes details. But at this point, I hope that you have a much better sense of how our application really works and how these two servers really behave together. In addition, I hope you have a better sense of some of the reasons that we decided to go with this flow at all. We got to completely skirt all these issues with CORS requests. We got to take advantage of using cookies for authentication, which is very arguably the most secure way of handling authentication, and arguably more secure than using JSON web tokens and manually passing them around inside requests. So we took this entire architecture for a good reason, and we only decided to kind of dive into what's going on behind the scenes so that we would get a better sense of what's going on. So I hope at this point that you better understand what our server is doing, and I hope you've got a much better sense of how we've really put everything together. So now that we've gone through all this stuff, we are really done with a lot of the very complex theory in this course. There's not a lot of other super intense stuff like this we have to get through. From here on out, it's mostly going to be about building the application. I will say that there is like the one last thing that we have to do around production or deploying to production with Create React App. So we might kind of revisit a couple of these topics when we deploy our application to production the next time, but we definitely won't do it as in depth as we have now. So with all this done, with all this understanding out of the way, let's take a break, continue the next section, and continue working on our app.